Well, the EcoHoist is a new mechanical bucket elevator that operates inside two small diameter mine shafts. So the advantage of that over existing skip hoisting systems is that the smaller mine shafts bring the capital cost down by a tremendous amount.
Today, our guest is Matthew Forrest. He's CEO and founder of EcoHoist, an amazing technology that helps us lower emissions in underground mines, reduce the operating cost of hauling ore to the surface, and the most amazing thing of all, it has a super low capital cost to allow us to make mines more productive. Stay with us and listen to this fascinating conversation. Tell me how you came to know about ReThink Mining. How did you run into us or our team?
I think it was through one of my team members, Michael Short, who's a mining engineer and has spent a bit longer in the industry than myself. And so when he started working with us, he knew of ReThink Mining and reached out to sort of arrange some conversations because there's sort of some overlap in our areas of interest.
Yeah, I heard about you for the first time just a couple of weeks ago when we met in that video call. But I was introduced to you and your company through Adam Garzinski, who's our man in Australia. And we're always looking for new technologies in Australia. 60% of the projects we do now are outside of Canada, even though ReThink Mining has its roots in Canada. So to start, tell our audience a little bit about your background and what was the inspiration for the EcoHoist technology?
My background's in mechanical engineering, computer science. So I started off thinking about robots and automating things. And then maybe 5 years ago, I came up with an idea for a new energy storage technology that actually involved using the machinery that we now call the EcoHoist to work as an energy storage system. And so things have gotten challenging on the energy storage front in terms of battery prices coming down and that sort of thing. But what we realized through the development of the energy storage product is that the equipment we'd come up with was actually really great for the mining industry to help decarbonize and basically to help lift rocks from underground.
I want you to describe what the EcoHoist is for our audience, but then I want you to tell me, how is that how could that have ever been an energy storage device? Because I don't get it. But let's give us a brief overview of what the EcoHoist is to start.
Sure. Well, the EcoHoist is a new mechanical bucket elevator that operates inside two small diameter mine shafts. So the advantage of that over existing skip hoisting systems is that the smaller mine shafts bring the capital cost down by a tremendous amount. And to the second part of your question, how was it part of an energy storage system? Well, essentially what we were developing was a gravity energy storage system, so lifting and lowering weights, much the same as pumped hydro, where you pump water up a hill and then let it back down again to recapture the energy. We were trying to do the same thing, but using crushed rock in underground mines.
So when I heard about it and you were using the term buckets, I was imagining a long cable going down to the depths with actual buckets attached to it. But then I saw kind of a schematic, and it was almost like upside down umbrellas, or I don't know how to describe it. A disc.
Like bowls, even like bowl shaped.
Bowls. So the ore would get loaded on that and then dragged up. I was thinking more of a Gilligan's Island kind of setup, a bunch of buckets attached to a rope. But this looks a lot more sophisticated. So tell me how those buckets work.
So the buckets are about the shape you described before. An upside down umbrella is probably actually quite a good shape description. And they're fixed to a mechanical chain. So instead of using ropes or cables like a lot of vertical hoisting systems use, we use a mechanical chain that has fixed rigid links, then engage onto a sprocket. And so that has a handful of mechanical advantages. But yeah, the bucket's attached to that. And that's what allows really good sort of efficient power transmission and movement of the material, as well as allowing it to be sort of gripped very strongly by the sprocket, which is lifting them from the top.
I understand that to get a skip hoist in, which is a traditional method for raising ore to the surface, you have to make a pretty big mine shaft, like 5 or 5.5 meters in diameter, which must be really expensive. And yours instead uses 2 smaller shafts. So tell us how that works.
Yeah, so a skip hoist would use mine shafts sort of upwards from 5 meters in diameter. 5 to 8, I think, is normal. And what the EcoHoist does is replaces that with two 1 meter diameter shafts. And obviously with the sort of cross-sectional area of a circle being proportional to the diameter squared, that's a huge reduction in the amount of rock that has to be removed. And additionally, because it is so much smaller, it means that we can use different equipment for constructing them. So with a large diameter mine shaft, you have like a big sinking stage that you drop down, and you often have people in the bottom of it drilling holes and drill and blast and mucking, removing the material. Whereas when the mine shafts are much smaller, in the order of a meter in diameter, they can actually be drilled using directional drills and raise boring. So it can actually be fully mechanized. It means you don't need to put people in the bottom of the shafts. It means it can be built a lot quicker. And also because they're smaller, there's less of a reduction in the geotechnical stability of the rock. And it also means that then we can use different lining techniques, such as installing a steel lining pipe, and that further increases the structural integrity of the mine shaft in its completed state.
So senior executive in mining I was speaking to today told me one of the themes that is on his mind for technologies that would be useful in mining is anything that gets them to the ore faster. So if we're imagining going down, I don't know, a kilometer, and I can drill these two narrow shafts versus one big fat one, how much time could that save me in getting to the ore?
The getting to the ore process, getting to first ore, might be much the same because you would still have to tunnel down to that 1 kilometer depth. But then the time from reaching first ore to reaching rapid production rate, the EcoHoist could reduce that dramatically. Particularly with the small mine shafts, we could actually run two raise boring rigs side by side in parallel, and that cuts the construction time of those shafts down to months rather than years for an equivalent skip hoist system.
And if you were to drop that shaft down there and put the EcoHoist in, what effect does that have on the work that's being done to allow the use of haul trucks? Does that work get minimized in any way or reduced in cost or time?
Yeah, one of the major advantages of the EcoHoist is it can reduce the amount of trucking that's used in mining generally. It depends a lot on the architecture of the mine, which is determined by the shape of the ore body. But in a lot of cases, what we've looked at is one where, maybe with obviously if you're extracting material using trucks, diesel trucks, then you need a lot of diesel trucks to do that. If you've got a skip hoist system that's a single large capacity centralized system, then you've got to truck the material a long way underground. And then sort of the best case is where you have multiple EcoHoists, because they're smaller and cheaper to install. You can do that. You have multiple EcoHoists around the different access points to the ore body, and that further reduces the distance that the material has to be moved underground using trucks, whether they be diesel trucks or even electric trucks. One of the advantages of doing that is reduces the cycle length, and that then makes it sort of technically feasible to use battery electric trucks, which is a pretty big compelling value proposition in terms of moving away from diesel trucks as well.
I don't know how often skip hoists break down, but I imagine if it needs maintenance or something happens in the shaft, that mine is out of production. So the idea of using multiple EcoHoists seems attractive as well, because you would still have some means to get the ore out. Is that right?
Yeah, it's redundancy. So it would be, if you've got three of them then, and one of them is down for maintenance or what have you, you've still got 2/3 of your production, which is enough to keep your mill running. Very, very different in terms of like what happens if.
So if I compare the EcoHoist to the two alternatives, which is haul trucks, let's say diesel haul trucks, or skip hoist, how do they stack up against one another in terms of capital cost and operating cost and speed or capacity?
It's sort of a difficult one to all put into one concise explanation, because they're all a bit different in terms of how they work and the trade-offs and the capital and operating cost. But particularly between the EcoHoist and a skip hoist, the capital cost of the mine shafts is like less than a sixth, just because there's so much less material that has to be removed. And then the EcoHoist, being automated mechanical equipment, it has a very low operating cost. And so similar to a skip hoist that also has low operating cost, it runs on electricity and it's largely automated. So yeah, it's kind of a trade-off between capital and operating cost. And then, on the other side of things, you've got trucks that are very high operating cost, typically, diesel as well as operators. you might have 4 operators on the books of the company to keep one truck running 24/7. There's a lot of extra cost with that, and you need many trucks to achieve the same production rate as one of the automated haulage systems of a skip hoist or an eco hoist.
But when you consider the capital cost and the operating cost, the chart I saw, the eco hoist is the clear winner in total overall cost for removing the ore, correct?
Yeah, if you make a handful of assumptions about mine life and cost of capital, you can boil all of those back to a lifetime haulage cost, and on that basis, the eco hoist is the clear winner.
So tell us a little bit about the process of how it's an energy storage device. Doesn't seem like you could store much energy with that. I get it, but it doesn't seem like you're going to store much energy with it.
So the second part of the energy storage system is one where you have stockpiles or large amounts of mass that you can move vertically. So the eco hoist is like the power conversion device in the sort of analogous case to a pumped hydro system. The eco hoist is the turbine, and you still need reservoirs, which are your stores of material, of mass.
So you're going to, by lowering material back into the mine waste, you're going to generate electricity. Is that what you're saying?
Yeah. And that's actually something that is a part of the EcoHoist's value proposition as well. One of the early customers that we've been working with, they had a processing plant on the surface, but it was actually a long way from the ore body that they were trying to mine. And they had some legacy waste on the surface nearby to the mine. And what they wanted to do was to return material back underground so that they could maintain the structural integrity of the ground. And they didn't want to use a whole lot of concrete because that's really expensive. And so we actually came up with like a double umbrella shaped bucket that could on one side lift the material, and then on the other side simultaneously lower material. And so that would sort of close the energy loop balance. And so, the energy of lowering the material would then actually be used as the energy for lifting the ore up out of the mine, as well as, basically getting twice as much bang for your buck out of the machinery.
If you can find a situation where they want to bring up the ore and lower the waste at the same time, you get to do it for free, or free of energy cost.
Free energy, yeah.
So how did you take it from that initial conception to where you're at now? What was the process in your head or in the work you were doing towards where you are today?
I mean, the process in going from an idea to a product, it's sort of, I guess it's fairly iterative. You start with, trying to do some engineering designs and calculations and research to understand, what materials are suitable, what are available, how much do they cost, and trying to sort of build that into a techno-economic model of the machinery, of its performance. And then as well, sort of continuing on to go like, how does that compare to the alternatives that that mines have? They're sort of the steps at a high level. It's go from idea, convert it to some actual engineering calculation and tests, and then sort of building up the whole picture of the techno-economics.
And what would you say was the major or the most difficult technical challenge to date in making that work?
I'm not sure that I'd frame any of them as big technical challenges, but one of the things that I think is the most innovative or the step which I think unlocks the EcoHoist the most is the realization that, if we change the architecture in a way that allows us to use a mechanical chain type of machinery, that then allows us to use modern composite materials that use fibers, and that those fibers of the composite material are very, very strong in tension. They're very strong and very lightweight, and that means that the self-weight of the EcoHoist is reduced, and that means that we can lift more material from a larger depth using that equipment. And so one of the big steps that we made was, we obviously conceptualized that. We knew that fibers were strong, but what we had to figure out was, how do we make that? And so what we've done is we've made some prototype of these chain links using our composite material, come up with a new manufacturing process to do that. And then we took that to a research lab and we tested them. We tested how strong they are and how long they lasted, how many cycles they would be subject to. And it performed better than we could have hoped for. So that was really the most significant, exciting development that unlocks the EcoHoist.
So I was imagining a gigantic steel cable. And then you said chain, and I was imagining a chain, but you're telling me it's a composite material chain, like links made of Carbon fiber
Yeah.
and what, epoxy or what?
Fiberglass is our go-to. It's a little bit cheaper and nearly as good performance. When I say chain, think motorcycle chain, not like hoop chain.
Okay.
So it's an engineered chain. There's engineered journal bearings and pins, and the links of that chain are what are made with the composite material.
That's amazing. I had no idea.
Of course, it's very big. Yeah.
What would be, if you were going down, I don't know, a kilometer, how big would that chain be?
So if you imagine a motorcycle chain, the pitch or the distance between the pins on a motorcycle chain might be 20 or 30 millimeters, 2 or 3 centimeters. For the EcoHoist chain, it's just like that, but bigger. And so the pitch of an EcoHoist chain will be about 1 meter. And so for a 1,000 meter EcoHoist, we would use 1 meter long pitch links. And so, roughly 1,000 links in that vertical section.
And fiberglass can hold the weight of the entire length of chain, buckets filled with ore.
Yep. So there is some derating with depth. Obviously, as you go deeper, you've then got more self-weight, and when you've got more self-weight, that reduces the amount of weight that you can put on there with rocks. But yes, fiberglass is a very impressive strength-to-weight ratio.
So I was thinking of all the things that could go wrong. You probably don't want to think about that, but if you probably have thought about it, though you don't like to.
We do. Yeah, we do think about that.
I imagine you'd have to have some process to inspect the integrity of the links. But the thing I worried about more is, what if the thing jammed? You're down 1 kilometer and halfway up, it jams for some reason. How do you avoid that, and how do you address it? I imagine it's the same potential problem with a skip hoist. So tell me about that.
In terms of the potential for jamming with the EcoHoist, we obviously spent a lot of time thinking about that, because with the small mine shafts, there's not so much room for access. You can't get people to it to sort of fix a jam. And so what we sort of think through is, what are the things that could cause a jam? And so there's a handful that can cause that. One is, when you're loading it, if you load more material on than there are buckets coming through, then that could cause a jam. But that jam is only situated at the loading chute. So that's actually like a relatively easy one to deal with. Plus, with the right control system on the material feeder, you can basically prevent that from happening, prevent it from being overloaded. The other potential cause is where oversized material is loaded onto the EcoHoist. And so we have a fairly tight requirement on what too big is in terms of material size. And also, obviously, you've got too big in terms of the rocks, but then also something that often happens in underground mines is there's what's called tramp material, like rock bolts or ground engaging tools. Pieces of metal often end up on conveyor belts and in processing lines. And so the EcoHoist will have obviously a crushing station to reduce the material size and a screen to sort of clear out or catch that tramp oversized material before it goes onto the EcoHoist. So they're sort of two of the potential blockage mechanisms. And then the final one, which could actually happen along the length of it, is one where, if it's maybe been too long between maintenance and a bucket has worn out and maybe a bucket drops some rocks and those rocks then flow down, that still wouldn't result in like a catastrophic blockage, because any material that's spilled will sort of flow down to subsequent buckets. There is still quite a reasonable gap between the buckets and the shaft, sort of in the order of 4 particle diameters. And so you need quite a lot of material there to cause a full blockage. And additionally, we design the buckets so that they're like volume constrained before they're mass constrained. And so what that means, if there's any sort of, if one bucket empties and loses some material midway up the shaft, then that will fall down onto subsequent buckets. And because of the geometry of the buckets, none of them will hold material it'll sort of spill off of those as well until the subsequent ones are filled. And we nominally operate the system with 80% full buckets. So in terms of like the volumetric capacity, all the buckets are running at 80% full. And if there's spillage or what have you, that can then be accommodated by the subsequent buckets.
So Matt, I want to say firstly, I'm a mechanical engineer. I work with engineers all day long, or I have for 40 years. And you had a very high level of confidence. I'm like, is this thing really going to work if we try it out? I'm like, oh yeah, it's definitely going to work. But you thought people might not believe you. So for people who don't believe you, what's your solution to pilot or test it or give them something to give them more confidence? What does that first little pilot look like?
The first pilot, what we're working on at the moment that we have designs for, is a 30% scale demonstration of the EcoHoist. And so 30% in terms of bucket diameter. Instead of the like half a meter diameter, it'll be, a third of that. And so that will, demonstrate the material handling capabilities, loading and unloading of the buckets, and that will operate at about 50 tons per hour, which is quite a bit less than the full scale system capacity. But yeah, that'll be something that people will be able to look at and go, yeah, there it is. It's working and operating. That will also, that's going to be a relatively small scale piece of equipment that will build in like a warehouse. It'll be maybe 6 meters tall. And obviously the self weight of something which is only lifting through 6 meters is much smaller. And so we've got some, mechanical trickery to increase the load on the chain, to put more force in it so that it represents what would be in a 100 meter or more lifting elevation situation. So we'll be testing both material flow as well as the structural aspects of the system.
So in the couple of months I've been with ReThink Mining, this is what I've discovered about the projects that happen with our members. Generally, when we make them aware of a technology or they say they want to investigate something, they form a consortium around it, those who are most interested. And they want to see the projects progress in steps. And that sort of 30% pilot would seem like a really reasonable step, I think, and probably something that would be attractive to our members to investigate the technology further and evaluate it. While that is underway, what they like to do is they like to plan the next stage and prepare the budgets, prepare how it's all going to look, find a location for it. So tell us, Matthew, after the 30% pilot, if that's successful, what would the next project look like that the members could participate in?
The next project after the 30% scale demonstration plant would be one at an actual mine site. And so we're in conversations with 3 different mining companies. One of them is a very large tier 1 mining company that's showing a lot of interest and has multiple sites that it would be of interest to. The next step would be to build one on a mine site in the actual underground environment, using the shaft construction methods and that kind of thing that we've sort of developed. And that would be configured. Obviously, it would still be a first of a kind in that environment, but it would be configured in a way that obviously there's uncertainty of whether it will work or whether what its uptime will be, that first one. But it would be really great that we have that at an actual operating mine in a way that when it is successful and when it is operating, it's actually lifting ore for them and creating value and saving them money with that first pilot or demonstration as well.
It's great when you have a mining company that's interested in piloting the technology already, because that allows the other members to participate, share the cost, and actually reduce the risk for the one who's most interested in piloting it. So that tends to be a very successful project for us when there's already a mine where there's some interest. What do you think is the style of mine or the qualities of a mine, an existing mine, let's say, where the EcoHoist is the best application? What does that mine look like?
All of the mines that we have been considering with these 3 different mining companies, they're all brownfield mines looking at doing brownfield expansions. They're all underground and they're all sort of constrained in some way by their existing methods, whether that be, our current skip hoist doesn't have big enough capacity, or it's too far away from the ore front, or our trucks are too expensive to run and operate, or we just want to get more out of the ground faster. And so in terms of depths, sort of beyond 300 meters deep underground covers most of them. And there's a handful at sort of the 600, 700, 800 meter mark.
So 2 other themes that came up in my conversation with this mining executive today were other things that were really important to him. And he said he wants to find technologies that will improve their productivity, number one. And the second one is decarbonization. So tell us a little bit about what this technology does for productivity and decarbonization.
From a productivity sense, the EcoHoist can sort of our nominal design will do 2 million tonnes per annum, which for most mines is a big chunk in terms of improved productivity. And because of the nature of the EcoHoist, that can sort of be built, adjacent to existing operations, so the construction process is out of the way. And then once it's operational, you can then be, extracting more ore without sort of risking getting in the way of existing production. In terms of the decarbonisation sense, there's sort of a few ways in which underground mines emit or create carbon. One of the main one, or one of the most obvious ones to begin with, is the use of diesel trucks. So if that mine was relying on diesel trucks and was constrained by them and the production rates achievable with diesel trucks, then an EcoHoist would obviously increase production, remove that bottleneck, and reduce the amount of diesel that's burned running those trucks. But a secondary big difference in the amount of carbon dioxide created is because of ventilation. And so when you're running an underground mine and you've got diesel equipment in it, you need to run a certain amount of airflow through the mine to clean out those diesel fumes so that it's safe for people to breathe underground. And the relationship between the amount of air you need and the amount of energy you need to move the air through, it's a cubic relationship. So if you can halve the amount of airflow that you need in your mine, then you need only an eighth of the amount of power of electricity to run that. And if you're running on diesel generators, or even if you're just taking your electricity from the local electricity grid and that has sort of embodied carbon in it, then a big reduction in your electricity use can also reduce your scope 2 emissions by a pretty tremendous amount as well. So there's sort of multiple ways in which eliminating diesel trucks reduces CO2 emissions.
Do you think we could eliminate all diesel haul trucks, or would there still be some haul trucks required? There'd still be some vehicles required other than haul trucks going up and down, right? Could we eliminate all of the haul trucks?
Yes, I would say it depends on the architecture of the mine. We'll definitely still need vehicles for moving stuff in short runs, whether that be boggers. But definitely, regardless of whether you need truck, you can run a mine fully electric. There was a recent study by ABB, Parenti, and IGO that explored how a mine could be. So this was a deep underground mine, about 1 kilometre deep, that had a hoisting shaft. And what the conclusion they came to from that was it might have been 6% higher lifetime cost to run the mine fully battery electric when it had a skip hoisting system. And so the equivalent would also be true with an EcoHoist. If you've only got short runs for your trucks and for your boggers, it would then be not much more expensive to run it fully electric if you've got a big vertical hoisting system to sort of cleanly do the heavy lifting of the mine.
If we're hoisting ore out with an EcoHoist and we compare the electricity required to operate the EcoHoist, is it the same as the amount of electricity required by a skip hoist?
Fundamentally, it'll be much the same because I guess if the elevation that you're lifting it through is the same and the amount of tons that you're lifting is the same, then that's the same amount of energy. There would be some differences in terms of the speed of operation of the two systems. So the EcoHoist runs at a steady state continuous speed of about 2 meters per second, which is like a fast walking pace. Compare that to skip hoists. They sort of have big buckets that move very quickly up these mine shafts, up to 18 meters a second, which I think is like 65 k's per hour. And of course, once you're at those sorts of speeds, like if you stuck your hand out the window of a car driving at that speed, there's quite a lot of aerodynamic drag, and that represents a loss of energy or a wasted energy, and so that would cause a skip hoist to use a little bit more energy. But I haven't done the numbers on that to know how significant that would be.
So if you think about a collaborative project between our members, one thing we would hope for, of course, is their attention. We'd hope for their funding, each of them participating by funding the project. Is there anything else that you would be hoping for from the mining companies? How else could they contribute to the project other than with their attention and money?
Well, I think probably a prerequisite is their attention, but an additional thing, with their attention, would be to sort of consider the operational requirements, or I guess sort of where I'm going with this is, there'll be maintenance items and other considerations, things that we can, the way that we design things or test things, if they can provide information, if we can better understand their situation, their perspectives, the things they need, how they like to schedule their maintenance, that kind of information about how things would be optimally integrated into their mine. Any sort of discussions, conversations, interactions about that can help us design the EcoHoist that sort of best meets those requirements for the mining industry.
So your technology is quite in an early stage, which is the kind of thing we love at ReThink Mining. But if you think a few years down the road, what's the dream? What's the EcoHoist company going to look like 5 or 10 years down the road?
The dream is that we have multiple of these systems in operation, multiple being built. We're seeing mines scale back their use of diesel trucks. We're seeing increased productivity. We're seeing copper mines producing more copper that we need for decarbonization. Yeah, really increasing the productivity and reducing the carbon intensity of the mining industry. That's really the vision.
That's what we all want, I think. So is there anything else you want to tell the listeners about EcoHoist that you think they need to know?
I think your questions have been very good, Don.
Thank you.
I think we've covered a good amount. Yeah, there's nothing that springs to mind as that we've missed.
Let me ask you one last question then. If you were to give advice to an entrepreneur or a young company where the founders are trying to bring innovation to a traditional industry like mining, what advice could you give them today?
I think it's the age-old advice in the sort of new thing space, which is spend as much time as you can with the people who would use the new thing to really understand what they need, what they think about, what they care about, what's important to them. That's I think what my advice would be. Just make sure you get a really good handle of that and keep doing it. Keep learning. Because I guess that's relevant to the communication and how you sort of sell and advertise and communicate the value propositions. Is you've got to make sure you're able to speak the same language as the people who can benefit from it.
Well, thank you for joining us today, Matthew. It's been a delight. I think that this technology is right up the alley of our members, and I think it's going to be something that really interests them. And I hope we could get a few of them together to talk about advancing the technology and finding some applications for it. So thanks for joining us, and good luck to you and EcoHoist.
Thanks for having me, Don.